Welcome. Today we're going to be talking about Snakemake, which is the most exciting thing that there ever really was. The lesson that we're going to be going through is from our summer workshop that we teach. It's called Angus. So if you go to the URL that's on the right side or the left side of the board over there, it's angus.readthedocs.io. And then if you scroll down or if you look for the word Snakemake, it's on Tuesday, July 9th from 10:40 to 12 p.m. and it's Snakemake. I'm gonna need stickies. Go to the yellow sticky if you're still thinking or getting organized or if your code is still running, and then bluish teal sticky for when everything's running, you don't have any questions, something along those lines. Thank you. Okay. So go ahead and put, if you're going to be coding along with us, go ahead and put a teal sticky up once you're at this workflow management with Snakemake link. Can I get some teal stickies? Just put a teal sticky up if you're planning on coding along. Okay, cool. Okay, so we can skip. So I guess some background. So today we're talking about Snakemake. So what Snakemake is, it's a workflow management tool. So it's a way for you to take your code and to automate it. And it does a lot more than just automate, but it's just really cool. It's really wonderful. My life was changed when I learned Snakemake. That's all that I really have to say. So I hope that by the end of today, you're convinced that Snakemake is cool and that you maybe want to try it with some of your stuff. So this is part one of a two-part lesson. We're going to see how far we get today. There is some initial setup so that we can understand why we would even want to use Snakemake to begin with. And I'm not quite sure how long that's going to take. So next week, we'll pick back up wherever we leave off, except Tessa, who I think half of you have met, will be teaching next week. She's with us remotely right now, but I'm not going to unmute my computer for everybody to hear her. Sorry, Tessa. Although, Tessa, if you have something to say, you could Slack Alicia or Hannah or maybe Karen, and they would tell us about it. Or Ellen, too. Okay. Oh, that's funny. So the first part of this lesson, like I said, we wrote this for the summer course that we teach, so we can ignore some of this, like accessing our Jetstream. You can do all of this on your local computer. We're not going to be doing anything intensive, but this lesson does assume that you have conda installed. So can I get green stickies up if you know what conda is? Teal stickies, I mean, and then teal sticky up if you have it installed and you plan on following along. Nicole, you have it too? Oh, that's great. Okay, cool. Okay, so from the get-go, let's go ahead and install Snakemake. Well, first, I'm going to start a new environment. So I'm going to do conda create-n, and I'm going to call this sm toot. So Snakemake tutorial. And inside of this environment, I want Snakemake minimal installed. And I also want the tools FastQC and MultiQC installed. These are the three tools that we're going to be using today. So what this will do is create a new environment that has these three tools as well as whatever their dependencies are already installed. So this is going to take a second to run. So what we're going to do today is we're going to talk about automating a bash script, one that you might use at the beginning of all of your read analyses. So what we decided to do, go ahead and type Y when this loads for you so it'll start installing, was to do the the first few steps of what would be a normal pipeline for working with sequencing data. So in this case, we assume that you want to run FastQC on all of your read sequences to get an idea of the quality that is within those sequences, and then that you want to summarize all of those runs, all of those quality reports using multi-QC. So what we're first going to do is walk through what a bash script to automate this might look like. This is funny. I knew something like this was going to happen. Okay, and then we are going to automate it with Snakemake. Okay, so what I just realized is that we don't actually have FastQ data to download, and I don't have a good way to give you FastQ data to download. So while I think of a way to solve this problem, go ahead and type conda activate and whatever the name of your environment was. Whoops. Mine was smtut for Snakemake tutorial. Whoops. And now I see that at the beginning of my path, I'm inside of this environment. Okay. And then the next thing that I want to do is make a directory that I'm going to be doing all of this in, and I'm also going to call this smtut. So I'm going to make that directory, and then I'm going to cd into this directory. All right, what is the best way to get you guys some FastQ data? Tessa, do you have ideas about how to give everybody the yeast FastQ or FastQ data?
Yes, I wasn't planning on doing yeast right now, but I have some small data on OSF. I actually probably have some yeast data too, but I was thinking about the NEMA data.
Oh, the NEMA data is great. Do you have an easy link that I can?
Yeah, I'm just looking for it. Just give me a sec.
Okay. What can I do? Does anyone know if I make a bit.ly to a Google Doc, is that easy for everyone to open? Yeah, okay.
Taylor, if you still have me off mute, I just put in a link for a gzip tar file.
Okay.
It has a bunch of NEMA data in it.
Okay. So if you go, let me make this bigger. If you go to this link, this is where we will put all of that data. Tessa, can you drop it directly into the Google Doc, or do you want me to go into Slack and grab it?
Okay, I just have to type into that Google Doc.
Oh, never mind, I got it.
Okay. I think that's a pretty small data set. If not, I have the yeast available, but I don't think I tar zip them, so that you'd have to download them individually.
This is fine. Thank you.
Okay. No problem.
Okay, I'm muting you again.
Okay.
Okay, so I'm going to type out a command here that we can use. wget-o data.tar.gz. And then we can copy and paste this into our tutorial directory. So this should be empty. And then running this, it says that it's downloading. Okay. And now if I type ls, I now have data.tar.gz. And then I can untar this with tar xf. Actually, we'll do xvf data.tar.gz. No. Yep. Okay, so we download it. If we had not specified where we wanted our output file to go, it would have just had the word download as the name, which is not very helpful. You want your file name to be less ambiguous than that. And so we give it data.tar.gz, which even is still not really that great of a name, but we want it anyway. And then untarring this file, which means decompressing it and getting back all of the individual files that are within this archive. We use the command tar and the flags xvf. V is verbose, X I think is, I don't actually know what these stand for. What? Extract, and then F is force. So this will give us back all of our files. Okay. And then we can see what we're working with by typing ls of NEMA extracted better names. Ooh, lots of FASTQ files. This is great because now this is actually a realistic situation where if we want to do quality control, it might be helpful to automate this in case of any multitude of things that might happen during that, which we will go over. Okay, but to start off, well, I guess, okay, so some reasons that we might be interested in automating this to begin with. I have on the left here some code that we're going to be going over. It's bash code, and this is the type of code that one might use to do this quality control analysis. So the first thing that we would do is change directories into our data directory. We would tell ourselves that we're running fastqc. We would tell fastqc to run over all of these fastq files. We would then make a directory to put these results into, move all of our files over, cd into that directory, and then run multi-QC on them. So this is, we have two commands, like two meat and potato commands that we're running here, fastqc and multi-QC, but we have a lot of scaffolding commands that we're also running, like change directory and move the files, and we tell ourselves what step we're on with echo and that sort of thing. And that's fine. But there's a few things that might happen if we automate and run this bash script. First of all, in this case, let's see how many files we're running this on. ls pipe to wc minus l. If I actually said, we have 23 files that we're running this on. So that's not so many, but let's imagine a situation where you're running it on 2,300 files. And let's also imagine that you're running on farm, which not so hypothetically fails frequently. And in the middle of, a farm is a compute cluster on campus. And in the middle of that running on those 2,300 files, something happens where the node fails and it stops running. If you want to not redo all of this work that you just did, you would have to move all of the files that finished running on fastqc and then respecify the ones that are not done to restart. And it would be up to you to determine if which one it failed on, first of all, and if the one that it failed on was corrupted or if it had actually finished running. And then you would restart the run and run fastqc and multi-QC. And that's not so horrible until your pipeline has 100 steps in it. And you have to do this for every time that there's a failure. And so one thing that's really great about Snakemake is that it keeps track of when all of those things happen. So if there's a failure in your pipeline, it keeps track of the files that are incomplete at that time and either removes them or you tell it to rerun it upon the next start. It also keeps track of each of the different steps and can submit them as different jobs so that the processes are untied from each other, which helps you so that you can parallelize the code that you're running, but it also helps in keeping track of which steps are happening as well. So those are a few of the reasons that Snakemake is really wonderful. There's a bunch of other reasons, and we'll drop little tidbits throughout the presentation. So does this structure of these commands look like something that you might have run in the past? Because understanding what's going on with this is important to understand what's happening in the next steps. So I can go over this in really detail if not. Okay. I had an error. Okay. Okay. It takes a long time. You can also use curl. So if you type Control-C, I'll write the command in the Google Doc with curl instead. In that case, you could either kill the process or you could exit out of the terminal. Oh my goodness. If the package manager is good enough, it will keep track of it. I never remember the correct incantation of the L's and the O's with curl, which is why I never use it. If I remove data.tar.gz, I can test if my curl works. Yes, it works. Okay. 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 So, okay, yeah. So what we're going to do then for the rest of today is work on automating this code. So in Snakemake, we'll automate the creation of directories. We can have statements to ourselves that tell us what Snakemake is doing. We'll run fastqc with this command, fastqc, and it'll run over all of the all of the files that end in fastq.gz. We'll make another directory that's named fastqc untrimmed. We'll tell ourselves what step of the pipeline we are at, and then we will automate the output of these to the correct directories as well, to the fastqc untrimmed, and then we'll run multi-qc on them. Okay. So a little bit more of an introduction to Snakemake. It's what's called a workflow management system. It's sort of a riff off of the system Make. So Make is a thing that software engineers used to use to build their software, and bioinformaticians sort of co-opted it and used it to build their pipelines, but it didn't really work very well. For example, Make files, you have to have one input and one output. Well, you can imagine in bioinformatics, oftentimes you have one input and 50 outputs, and Make couldn't really handle that appropriately. So Snakemake was born out of this idea that we needed a workflow management system for bioinformatics specifically. So it's written by a bioinformatician for bioinformatics workflows. It's used for other things as well, but it works really well in this use case specifically. It's also free, open source, and conda installable. It recently moved over to GitHub, so you can see all of a bunch of people who use it. There's different people who contribute to it. You can see different issues that are on there. And it's really nice that it's on conda because it makes it quick and easy to install on any system that you're working with. So it's cross-platform for Windows, Mac, and Linux. And then that means it can also work on HPCs. But there's even more treats associated with it. It will schedule all of your jobs on an HPC as well. So I have now I got access to Farm in June of this year, and I have ran over 100,000 jobs without ever writing my own Slurm script because Snakemake does it all for me. I still don't actually know how to write a Slurm submission script because Snakemake is just that great. Please don't tell other people that because then I'll have to learn and that sounds annoying. Anyway, okay. It's written in Python, which is also really wonderful if you know Python, because you can use direct Python code in the script itself. Python is not my favorite language, and Snakemake is still my favorite. So it also interacts well with R code and with bash code. But it is really handy that you can write Python code directly into it. And so the pros of using a workflow management system in general is that it allows you to keep record of where your scripts are, what the scripts do, what their inputs and dependencies are. So it keeps you really organized in your workflow. And it's usually all in one file or in one system of files that are all well documented together. So it's also easy to give that to somebody else and say, here, this is what I did. It's possible to parallelize your code when it's written in Snakemake. It solves which things depend on each other. So for example, it would not try and run multi-QC before we had finished all of our fast QC rules, but it would run all of the fast QC things all at once. And then it automatically detects if something changes and you need to reprocess the data. So if you got more sequencing data back from the sequencing core from step 1 and you doubled the size of all of your libraries, it would detect that that occurred and rerun every subsequent step to adjust to that new data. So I'm gonna actually make this bigger for a second, if I can. Where are we? There we are. Okay, so this is the anatomy of a Snakemake rule. So this is what Snakemake works on and what the syntax of Snakemake looks like. So everything occurs in rules. So each step of your pipeline, each modular step becomes a rule. And we give each of our rules a name, and you'll see that they look, if you know Python, a little bit like a Python function might look. So it's a similar syntax to that. Then you have an input where you give it the name of your input files, and then an output where you give it the name of your output files. So in this case, our input are all of our files that end in fastq.gz, and our output are our files that end in fastqc.html and fastqc.zip. And then this is what it looks like if you're going to run a shell command. You tell it that you're running something in the shell. You have to partition off that code from everything else, and then you write the script in here. If it's a multi-line script and you've bracketed your shell command like this, you can press enter as many times and it can be as long as you want. But in general, it's a good idea to break off each piece of your analysis, each step, into a different rule. And the nice thing about the way that we have this written is that you specify your input And then because FastQC is weird, instead of specifying the output file, you specify the output folder. But Snakemake automatically solves the directory structure based on the input and output names. So you don't have to make all of the directories yourself. So all of your cd, mv, and make dir commands sort of disappear from your pipeline, which is nice because then you're left with just the actual functional pieces. So it's a little bit easier to read what your command is doing. Right, okay. The other thing that is nice is that wildcards, which is what we have here in brackets and in yellow, generalize the rule across your different samples. So we've created this thing called sample, which we can either define in a config file, higher up in our Snakemake file, or it can be, it used to be able to be automatically solved, and you can still kind of do that, but you usually define this someplace else. You tell Snakemake where the definition is, and it'll put all of your sample names in where it needs to go. So you only need to write one rule, and it'll apply over all, in our case, 23 of our files, or if you had 2300, over all of those as well. And as this states, it's also not, you don't have to list every single output. You only want to list the ones that you want to monitor the output. So if it's an output of your whole pipeline and you want to see that file, then you would list it here. Or if it's the input of a subsequent rule, then you need to list it as an output as well. Questions about Snakemake rules? Okay. Okay, so we're going to make a snake file, and it's going to look like this. So you can copy and paste it if you want, except that we're going to have to edit it. So we're going to copy and paste it, and then we'll edit it the way that we need it to be. So I'm going to copy this, and then come back over to my terminal. And then my favorite tech, well, let's go up one level. So I'm just in my tutorial, and I see that I have my data.tar.gz, my NEMA extracted better names. So the first thing I'm going to do is move this NEMA extracted better names to a folder called data, because it's shorter. And then I want to make a text file. So you could use Vim or Nano, or if you have a text editor on your laptop, you could do any of those things and save this file. And I'm going to call this snake file. So in my case, I typed Vim snake file. And then I press I to start editing, and I can paste this rule. You might not have syntax highlighting, and that does not mean that it's broken. So I'm going to get out of this for a second. Oops. If we look inside of this data directory, we see that our files start with 0s1 extract 1, 0s1 extract 2, and so on and so forth. So I'm going to copy this, oops, here, this 0_s1 extract 1, and then I'm going to go back into this file. So originally this was written for a different set of files, ones that had the accession number ERR458493. If I want to do this over the files that we have, what changes do I need to make to these inputs and outputs for it to work? I just want it to work for one so far. Yeah, so the only thing that I need to change is get rid of this ERR thing, because we're not actually working with that file, and instead put in our 0 hour F1 extract 1 instead. And now this rule would apply to the data that we have on this computer. Our input file is in data, that folder data, and then we want our output still to go into fastqc_raw, and I changed the file prefix to our file name. So if I write this file out and then get out of this, if I type ls, I see that I have a snake file. There we go. Okay. And now we can run this by typing Snakemake. Ooh, my very favorite colors, green and gold. It runs. So when Snakemake runs and it's running correctly, you get green and gold output by default. You can change the colors if you want to, although I haven't actually figured out how to because I'm a really big Ducks fan, so I love that it sends green and gold to my screen. The black is what's printed out to the shell based on what the program itself actually ran. So this is the standard out that's still getting printed to the screen, and then the green and gold is from Snakemake. So it tells us it finished job 0. It finished one of 1 steps, and it's 100% done. And it created a log file in this hidden directory .snakemake under our logs, and we could go and look at it if we wanted to. So we have now just ran our very first snake file, which is terribly exciting. So our output started like this, and it scrolled past pretty quickly. Let me scroll back up. So the first thing that Snakemake tells us that it does is building DAG of jobs. This means that it's building a directed acyclic graph, or like the dependency structure of what it needs to run. So it's telling you that it's figuring out which rule needs to be run first and what rules need to be run subsequently and in what order. It figures out some stuff like which shell we're using and how many cores there are, and then it counts the number of jobs that we have to run. It has to run fastqc_raw, which is the one that we had encoded, and so it has a total of 1, and then it starts running. So that's great. We now have ran 1 fastqc job. And we can check that this actually ran. So if I type ls, I now see that I have a fastqc_raw folder. I didn't create that. Snakemake made it for me. And I can look inside of fastqc_raw, and we see that we have the fastqc output folder. So it really did run. So that's good. I don't understand. Okay, great. So now we can create a whole pipeline where we're going to run fastqc first, and then we're going to run multi-QC next after that. So to do that, we have to add another rule. So we see that we have the same fastqc raw rule here, and then underneath it we have a new rule called multi-QC raw. So if I copy this, I can put it into my file. Also, you can add comments because this is Python code. A Python comment looks like this, so we could tell ourselves what this rule is actually doing, and that's a very good idea to do in general. And again, I need this other file prefix, so I'm going to copy that. And change these out. And the only thing that multi-QC needs is this .zip file. So we might have wanted to see the HTML file output, so we put it in our output to keep track of it. But multi-QC only needs the .zip file. So that's all we need is input to this. And then the output is going to be in fastqc raw multi-QC report.html. And the shell command to run this is multi-QC. We give it the output directory, and we give it the input directory. Okay. So if I write this file out, I run it again with the same command, snakemake. And this time it said building DAG of jobs, nothing to be done. Why? So it didn't catch that we wanted to have it run multi-QC. And the reason why is because Snakemake requires a rule all. So the all rule is either is going to default to the rule named all, or if you don't have a rule named all, it's going to default to the first rule in the file. And that's the one that it's going to use to solve for all of the outputs that it needs to produce. So in this case, our rule all only, it has a doc string, because again, this is Python, so you can write a Python comment like that. And then it has an input where the name of the file, the final file that we want created is the only input there. So in this case, it's multi-QC report.html. So we need this rule all to tell Snakemake that this is the final file that we want created, and it needs to figure out every other rule that needs to be run to produce this file. So if I copy this, and go back into our snake file, I like putting my rule all at the top so that I know what my final target of my pipeline is, and I can paste this in. And now I see that I have a rule all, I have the doc string, and then the input is the last file that I want, or the file that I want created. You can put multiple files here, but in our case, the last file we want created is only multi-QC report.html. What's going on? Yeah. Conda comes with defaults, so you can still talk to the default channel. You just can't talk to any other channel. Okay, so now that we have our rule all, if we come out and run Snakemake, it now knows that it sees that we have a rule all. To produce the rule all, it needs to run multi-QC raw. So that's 2 total jobs, and then it runs it, and it produces our output file for us. We get only green and gold and some black output from the standard out. And we can check and see if this ran by typing ls of fastqc raw. And we see that there's a multi-QC report.html now in that folder. So another cool feature of Snakemake is that it builds these directed acyclic graphs for you. So it now has 2 processes that it needs to run, and it's keeping track of. The rule all is when it's finished running. To produce this, it needs to run fastqc raw and multi-QC raw. So you can make these DAGs. This was made with Snakemake, and then piping it to another program called Dot, and then it automatically produces this. So these are really nice, both when you have a presentation and you want to tell people what your pipeline was. You can make this, and then you already have a DAG, and you don't need to do anything else. or when something's not working correctly in Snakemake, you can make a plot of this and see what things are pointing wrong to each other, and it helps to debug what's going on. So it's a way to visualize what's happening underneath the hood. Okay. I think we can go through this. So if we want to process multiple files, the way this ends up working is we have to define what our file prefixes are. So that, since this is Python code, we use a list to do that. And so in our case, we would define the samples that we want it to work on in that list. So let's type ls of data, and we see that there's a bunch of different ones. I don't want to delete fastqc from each of these, so I'm going to run a command called base name. Actually, so no, I'm not going to do that. We'll just copy and paste. Let's pick 4 of these files that we want to run it on. There are many ways you could do this that would be faster than what we're about to do, but this one's the simplest, so we're going to do the simplest. If we come back in to our Snakemake file, I'm going to make a variable called samples, and it's a list, which in Python has the syntax of having brackets around it, and then each thing is in quotes. So get rid of that. And I'll paste this in the Google Doc when I'm done, so you don't have to do the same thing that I'm doing if you don't want to. Okay. There's just really not a good place to put this little bar. Okay, so we can put that at the top of our file. And then once we have this, this is telling Snakemake which files we want it to run over. But so far we've hard-coded our files here. So we need to replace this with a wildcard. So anywhere that we have that specific file name, I'm going to go through and delete that and replace it with sample. And then Snakemake will use the sample variable that we created to figure out what string actually goes here and which files it should be working on. Can anybody guess what sort of problems we might encounter with this right now, though? If not, we'll just run it and see what error message we get. Let's run it and see. Okay. So if I run Snakemake now, okay. If I run Snakemake, it tells me that there's nothing to be done. And that's because in fastqc raw, multi-QC report already exists. So I'm going to remove this. You don't have to do this part. Just want to show you what the error message is going to be. And if I run Snakemake, multi-QC is too smart for us. Okay. Well, it ran, but it only ran on one file. So it ran on the one that we are already finished on. And the reason why is because we never told Snakemake anywhere where to define sample from. So even though sample and sample in all caps match each other in Word, they don't actually match each other in their meaning or what they're referring to. So the last thing that we need to do to make this work correctly is we have to tell it that there's multiple inputs. And we do that by expanding our input and saying what sample actually means. So we tell Snakemake that in this case, to expand the thing that's in the curly bracket, sample, by our list samples that we have defined above. And in doing that, it will now take in all of the FastQC files. It will realize that it needs FastQC files for all of the other samples as well, and then run multi-QC on them. So if we add this line, and we rerun Snakemake, we still have to remove the I'm sorry. I don't know why that's happening. Okay. We need to remove the FastQC from multi-QC. And then we can run Snakemake. And now it's going to run FastQC over all the other files that it hadn't finished on. Wow, that's annoying. Well, that's where I'm going to stop anyway. What questions do you have about what we covered? Yes.
The reason why we only have to expand the last rule is that's because the first rule is
Exactly. So it says at the last time that it sees sample, the last rule in that dependency that it sees sample, it says, okay, you're defining sample here. I now know what sample refers to, and I can back propagate that through all the other rules. So you only need to define it that one time.
you need to define it.
I'm going to turn this off.
In the rule that generally whatever you define in the input.
Sorry, can you say that again?
You only need to do the expand. You only need to expand the code that generates whatever file you specify.
No, you use the expand wherever the last time that you see the variable is. So in our case, we just saw it in the rule before the rule all, so we used it there. If the last time that you see it is in the rule all, then you use it in that.
Oh,
there.
I see.
Yeah, so it's the last time that you see that wild card is where you use the expand. But then Snakemake will know to back propagate it through everything else. Yeah. Other questions? Yes.
Last time you see it in the pipeline, last time.
The last time you see it in the pipeline. Yeah. So my actual workflow when I'm writing snake files is usually once I know that that code works and I know I'm going to use it in my pipeline, then I add that rule. And so so I'm always aware of when that last time is, because I'm not just throwing a bunch of rules into a file, given my workflow. Yeah. Okay. Sorry, that was a little rough. Next week, Tessa will do better and talking more about like different tips and tricks for using Snakemake and those sorts of things. Tessa, do you have anything you want to say? I'm taking you off mute. No. Okay. Okay. Well, if you have any more questions, we are here to help you work through anything, and we hope to see you next week. Oh, next week we're going to be at a different location. We're in Valley Hall because the Christmas party for this building is going to be in here, and they kicked us out. Sad. And we hope to see you there. It's probably my computer. I have really bad luck with these ports.
Okay.